All right, welcome back to week 5. We're going to finish up our talk on topic 4.3, which is dispersion and measures of central tendency. And we're going to look at two other methods or two other measures that tell you about how the data is clustered or spread out. All right, if you've got two sets of data, so you can tell just by looking at the box and whisker plots that the set of data on the bottom is much more grouped together than the data on the top. However, what's interesting here is that both sets of data have identical means. So the average for both of these is the same. All right, our average right here, 15 and 15. Okay, the medians are also the same. So the middle value of each one of these, the 50th percentile, is the same. All right, the mode is the same in each. They both have a mode of 13. And then the range is the same. So the range is your max value, take away your minimum value. Your max value, take away your minimum value. So they share all of these things that are identical. However, you can see that the data is very different because of how it's spread out in one and not so spread out in the other. And that really, where we could see that is if we looked at the interquartile range, which is Q3 minus Q1. So this one has an IQR of 3. And then up here we got 23 take away 5. So this guy's got an IQR of 18. Which explains the spread in the data. Now this box down here did not have a top whisker because there were no values that were in that data set that were within 1.5 times the IQR. So remember, to get an outlier, we took 1.5 times the IQR, which in this case is 3, and that would give us 4.5. So if we took this upper quartile, which was 16, and we added the IQR, the top whisker would be anything that is less than or equal to 20.5. Well, there are none. And 16 turned out to be the upper quartile. So that's why this doesn't have a whisker on it. All right. So we want to take a look at two other measurements that are a little bit more detail than looking at the range and looking at the IQR. All right, these two additional measures are calculated much more sophisticated method because the IQR just uses two values. It just uses Q3 minus Q1, and the range just uses the max minus the min. So those two measurements of spread only use two values. So a more accurate view of the spread or the dispersion or how the data is clustered or is done using what's called the variance and the standard deviation. What variance and standard deviation do is they take every data point in the set and they calculate how far that data point deviates from whatever the average is for that data set or the mean. So it's using every single data point to come up with a descriptor as opposed to just two data points. All right, so on the next slide here, there's a link that takes you to this GeoGebra page. That's a really good visual way to understand what standard deviation is. All right, so over here on the right, I'm just going to click up here where it says random Y data, and all it's doing is just graphing those purple points randomly. Okay, so that's the set Y up here. All right, down here, the gray set, that's set X. So there's two sets of data up there. All right, what we're going to do first is both standard deviation and variance are based on the mean. So if I've got 10 purple points, 10 gray points. So I'm going to calculate the mean. All right, the mean of the purple set, that's the upper set, is 9, and the mean of the lower set is 10. All right, so that's just adding these up and dividing by 10, adding these up, dividing by 10. Okay, now what the variance is measuring, okay, the variance takes the data point, okay, so for example, okay, let's take a look at this set X, that's the gray ones. All right, it has a data point that is 1. Its mean is 10. All right, so what's going to happen to get the variance for this set? We're going to take each point and figure out how far it deviates from the mean. So for example, this first point is 1. It's to the left of the mean, which is 10. So I could do 1 take away 10. That's equal to -9. All right. Then I'm going to do that. There's 3 other ones, so or 2 more. So I'm going to have 2 more -9s. Okay, then I'm going to do it to the 5, so it would be 5 take away 10, -5. Okay, then I have one that is right on the median, so that's 10, 10 take away 10. Okay, 12 take away 10. So that's what these red segments are. They're what we're calculating is how long those red segments are. Okay, there was another 12, and then 19 take away 10. And then a 20 take away 10. All right, now we want to add those up, but the problem is when you have positives and negatives, some of those are going to cancel each other out. All right, and in the formula, you don't want that to happen. So in order to get rid of those, you square everything. And then you simply divide by the number of data points that you have, which in this case is 10. Now, when you do that, that calculates the variance. That's what the variance is. To get the standard deviation here, all you do is take the variance and take its square root. So when I click on standard deviation, that's what that's telling me. That's how you calculate standard deviation. Now we'll be doing it with a calculator, otherwise it gets kind of cumbersome to do. But what you're looking at here is the gray points have a larger standard deviation than the purple points. So what that's telling you is that this data is more spread out with respect to its mean than the set of data up here. This data is closer overall to its mean than the data that is the gray points. Okay, so showing you the steps on how that's done, if I just click on this part here, okay, we did it for the black data set. So you can see those were the numbers that we got. I squared them, okay, divided it by the number of data points. So I subtracted 1, take away the average, 1 take away the average, 1 take away the average, 5 take away the average, etc. Squared those, divided it by 10, and then took the square root. That's the standard deviation. When you don't take the square root, that is known as the variance. So that's what those two things are telling us. Okay. Now, data, the one downfall or weakness to standard deviation is that it's based on the mean, and the mean is very susceptible to very high values and very low values. Where standard deviation is very powerful in terms of describing spread is if the data is normally distributed. So if we have data that is in the shape of a bell curve, like ACT tests, SAT scores, those tests are set up in such a way so that the scores are normally distributed. So what happens in normally distributed data is that the majority of the scores, about 70% of them, are going to fall either one standard deviation above or one standard deviation below. That's where the majority of your data is going to be. So when I click on this link, this little box here, what it does is it shades in a standard deviation to the right and the left of each one of these means. Okay, so this orange box here represents one standard deviation to the right, one standard deviation to the left. So if you were to look at this first set, the set that's Y, all right, how many of its data points fall within one standard deviation? Well, there's 1, 2, 3, 4, 5, 6. All right, 6 out of the 10 data points for the Y set were within one standard deviation, plus or minus. Whereas on the other set, the set X, there was only 1, 2, 3, 4. Okay, only 4 out of 10 points. So this one was 4 out of 10, and the Y set was 6 out of 10. So that's telling you that this is going to have this is more clustered around its mean, than this set, which is also verified by the size of its standard deviation. So that's what standard deviation is. So our standard deviation is how far each point is. It's a measure of how far each point is from its mean. All right. When we're talking about standard deviation, you'll see the symbol sigma, lowercase sigma. Okay, your uppercase sigma, it looks like this. That's your lowercase sigma, and that stands for standard deviation. The formula is simply the square root of the variance. All right, so here's what you got to understand what you're looking at here. All right, all this means is that symbol means find the sum. This means you take a data point, so you take a value from your data set and you subtract, that is the average or the mean. So there's two types of notation, guys, and it can get a little confusing. Both of these stand for the average or the mean. One refers to the average of a sample, and the other one refers to an average of a population, which we'll talk about a little bit later. Okay, but so for now, you just need to know that, hey, these mean average. Okay. So what's going on here is you're taking each data value and you're subtracting the mean. Then you're squaring that, and then you're adding all those up and you're dividing it by the number of data points that you had. That gives us our standard deviation. So these were the steps that we did to get the variance. Okay, it's the average of the squared differences from the mean. So the first thing we did was we found the mean. Then for each number that we had, we subtracted the mean, and then we squared that result. And then we added all those up and divided it by the number of data points. This is the variance. When we take the square root of that, it becomes the standard deviation. Okay, so these are the two formulas. I already talked to you about how they were calculated when I went through the GeoGebra applet. Okay, so now I'm going to show you how to do it on your calculator. So I was looking up TI-84s to see if anything was available on Chromebook, and apparently because of the schools being closed down, that Texas Instruments is offering a Chromebook TI-84 emulator. Okay, because we can't install the Rabbit Toomey ones that we were using while we were in school on a Chromebook. So I'd like you to try to open that, and these screenshots take you through on how to find the variance and the standard deviation, and it's pretty straightforward. And then we're gonna do that down here in a second. Okay, so we're going to use our calculator now. Hopefully you were able to install that and it works. I don't have a Chromebook, so I don't know if it does or not, but keeping my fingers crossed. All right, so I'm going to do it on one of the calculators we had from school. All right, so the first thing you got to do is you got to get these two data lists into your calculator. All right, so you're going to press Stat. All right, and you're going to highlight one, which is the editing screen, and hit enter. Now what that does is it gives you two lists, and we're going to take the data from the first thing that we looked at, set A, set B, earlier in the Google slides, and I'm going to enter those data points. So it's pretty straightforward. It's just after each one you just hit enter. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. And then to go over to this other list, I just use my arrows. And now I'm going to type in that data. All right. Now, once you're done entering the data, so this is list 1, this is list 2, we're going to press Stat, and we're going to go over to Calculate, and we're going to choose one variable statistics. Okay. I want to get just the one variable statistics for list 1. So the frequency list, I'm going to leave blank. We're going to use that later on. All right. And so I'm just going to skip that one, and I'm going to go down to Calculate and hit Enter. And there's my one variable statistics. Now, you have to understand what you're looking at here. All right. So this is your average. So back here when I did these two on GeoGebra. Okay, there's our mean. All right, now what you have is you've got these two. That is a standard deviation, and this is a standard deviation. All right, so what you're looking at here, over here on our left here, it's just in the reverse order. You have sigma, and then you have this one that is S. Both of these are standard deviations. Okay, the one that you want is the sigma. That's this right here. Okay, so they're both standard deviations. One is for a population, one is for a sample. So this would probably be a good time to discuss what's the difference between those two. All right, here's the difference between the two. All right, so a population, when we're dealing with standard deviation and variance, there's a difference between population and sample. And the difference is very slight, okay, because I'll show you in a minute, the difference in the formulas is very, very slight. A population means you're working with all of the data for out of a particular set. You're not just taking part of the data. So if I wanted to find the height, if I wanted to do a statistical analysis of everyone's height in our class, all right, well, we got 17 students, so I don't need to do a sample because there's only 17 students to work with. So that would be an example of working with a population. Now, if I wanted to say, I'm going to use our IB math class as a way to estimate the height or to get a statistical analysis of the height of juniors at Florence High School. So instead of measuring every junior at Florence High School, I'm going to just measure the students in my class. All right, and then use that to make a generalization about all of the juniors at Florence High School. That is a sample. The only difference in the formulas is that instead of dividing by the number of data points like we did earlier, you do that when you're dealing with a population. When you're dealing with a sample, you divide it by n minus 1. So if there was 10 data points, you would divide it by 9 data points. Okay, that's the only difference between those two. So population, the way I remember which one is which, sample uses the letter S. So S squared is the sample variance, and then S is the sample standard deviation if you were working with a sample. The Greek letter sigma refers to population variance if it's squared, or population standard deviation. Okay, so if you're just working, most of the time you're doing, you're working with populations. You're going to be given a list of data points and you're calculating the standard deviation for it. All right, so our standard deviation was 8 for that. Now, if you scroll down using the down arrow, you get your 5-number summary. Okay, there's your min, there's your quartile, your first quartile, your median, your upper quartile, and your max. All right, now to go back and let's get the standard deviation for this second set of data. All I do is go back to stat, go to calculate, choose one variable statistics, and now change my list from L1 to L2. So to do that, you go second, stat, and that takes you to the lists, and then you go down to list 2. Okay, there are no frequencies in this data, so we skip that. We go to calculate. Okay, and then that should mimic this data right here. Okay, there's our sigma, there's our standard deviation, which is right here. And then if we scroll down, we get our 5-number summary. Which is right here. Okay. All right. So let's take a look at some examples here. All right. Now, what the section questions are that are a little bit different than the examples that we did in the lesson is that the data is listed with, it has values, but then it also has frequencies. So this is the same thing as me just listing out, okay, there was a 90, a 91, there was 486 meters, okay, there was 185 meters, etc. Okay, that's what that's telling you. So here's what we're going to do. To do the standard deviation and to get the 5-number stats, we're going to put the distances that they threw in list 1 and put their frequencies in list 2. And then what the calculator will do is it'll multiply these for us, and it'll find the average and then do all the calculations for us. So we just go to list, or excuse me, stat, and edit. Okay, to clear a list, if you just go to the top, okay, and highlight the list and hit clear, okay, it'll clear your list. All right, then I'm going to highlight 1, hit clear, enter, and it clears my list. All right, so list 1 is going to be the distances that they threw. These are pretty good javelin distances. And then over here on list 2, we're going to put their corresponding frequencies. Okay, and then it's simple. Stat, calculate, one variable statistics, Now, list 1 has our distances in it, so I'm going to go second list, change that to list 1. Now my frequency list is in 2, so now I'm going to fill in list 2 there. So second list 2, and then calculate. And there's my standard deviation. So it says round it to 3 significant figures. So in this case, my standard deviation is going to equal 1.96. And if we needed any more information, the 5-number summary, there it is. Okay, now if and I didn't put an example on your notes of this, but if this here, instead of it being distances, it was intervals. All right, so let's say that this was like between 90 and 92 meters. Okay, and let's get rid of those. Let me do it like this. Hold on. So if you were given class intervals instead of single values, you use the mid interval in order to do your analysis. So I would be using, my list 1 would be made up of 83, 85, 87, 89, and then my list 2 would still have my frequencies in it. I just use the mid value of each interval. So for my next question, it's just like the previous one, except it's asking you for the mean along with the standard deviation, the first quartile, the median, and the third quartile. So I already put the data in. This was L1, L2, and then it's simply stat, calculate, one variable statistics. My list is in L1, my frequency list is in L2, go down to calculate, bam, and there's my information. Okay, my mean 15.9. Okay, sigma, my standard deviation 2.0. Well, it's a 1 decimal place, so this would go to 2.1. And then if I go down, I scroll down. Okay, first quartile, median, third quartile, and I've got all my information. So you got 20 clubs in a football league. Now this is soccer in the 18-19 season with the following number of goals per club. Use the data to determine which choice best summarizes the number of goals per club. So this is your average value here, and then this is 1 standard deviation above and 1 standard deviation below. So you're just entering one list. You don't have to worry about frequency, and then it's do your 1 variable statistics. So again, to clear a list, just highlight the list number, hit clear, and then enter. Highlight the list number, clear, then enter. Okay, so I'm going to go ahead and type those in and then be right back. All right, now it's just hit stat, calc, 1 variable stats. L1 is my list. L2, there is no L2 list, so I'm just going to clear that and then go down to calculate. All right, so my average is 49.85. So if I rounded that, I know it's going to be somewhere, it's going to be either choice 1 or 2. Now I'll go down to my population, my sigma, and that would be the statistic that would best summarize the goals scored per club. All right, we'll see you next time.